In this video, I'm going to try and use a CMX Clean machine to clean the railheads of the track on my model railway in N-gauge. How hard's that going to be? So this is the thing that we're looking at today. It's called a CMX Clean machine, and the idea is you can use it for cleaning the railheads on your track. Comes with some instructions, so that's helpful. And the first thing I'll tell you about this is it's really, really heavy. It's made out of brass, actually. It's made out of solid brass. There's no plastic sort of parts on it, and the idea is that it's solvent resistant, so you can put different solvents in it, but we'll get onto that in a moment. The fact that it's really heavy means that you need a bit of oomph in order to pull it around the track. But anyway, you drag it round and it's got this this sort of pad on the bottom. The pad is sort of spring loaded, but that's the bit that runs along the tops of the railheads. And while it's going round, there's a little hole, there's a little valve just here that drips solvent onto the pad. So as it's going round, you've always got more solvent going on. Now, because it's really heavy, I say it needs a bit of oomph to pull it round, and there's a certain amount of weight that gets transferred onto the railheads through this spring here. This is the pad spring loaded. It's an American product, and that means that it comes fitted with couplers. They're called KD couplers, and I'll show you what these look like. But it's a much finer coupler than I'm used to. I think the ones that I'm used to using they're called rapido couplers, and in fact here I've got one of each on either side. The reason I've got one of each is because it comes, or where I bought it, it came with a couple of extra trucks. Call them trucks. That's what in England we call them bogies. In America they call them trucks, and so it's got replacement trucks with rapido couplers. So the first thing that I'll need to do is to swap over the other truck so that I can have a rapido coupler on both ends. Now I mentioned solvents, so the idea, you can take this this top off and you can fill the tank with whatever solvent you want. You could use water, but I don't think it'd be very effective. IPA sounds like a good option. You could even use acetone if you were that way inclined. I know acetone is really tough on plastic, so that might not be a good idea. I'm sure you get plastic on your point work. You get acetone on your plastic parts of your point work if you weren't careful. I know there's various other cleaning solutions that people swear by or swear at, depending on your taste. So you can put whatever you want in it. And the idea, there's two things you can adjust. So this thing here on the top adjusts the drip rate. It affects the rate at which the valve at the bottom there lets the solvent drip out. And here is the lid. You can take this off completely in order to put more solvent in, or you can just loosen it up, and that opens an air valve at the top, which allows the air in and therefore lets the solvent drip out the bottom. So you can use this. It comes with various spare parts. So I've told you about the trucks already. It comes with a syringe, so that's useful for putting your solvent in. We'll have a look at that in a moment. Comes here with some spare gaskets. There you go. There's one spare gasket and another, two different sizes. And it also comes with this length of fabric. So this is a sort of special fabric. It's sort of corduroy, very sort of short length corduroy. Anyway, the point is it sort of loops round, and although it's got a bit of depth to it, it's not going to catch on your point work or the other sort of sticky out bits of your track. So that's the problem. If you just run a J cloth or something around your track, that'll just get ripped to shreds on the point work. But this won't. So that's good. So you get a length of spare this, and you can replace the pad on the bottom here. There's a couple of little clips that you clip up, and then you put a new pad on. This is obviously discoloured on the bottom because I've been using it already, but eventually I'll need to replace the pad. Right, well, before we get going, I think the first thing I need to do is to replace the truck. So I've got rapido couplers on either end, so let me have a go at that. So this is the truck that I need to change. I just turn it upside down, and here there's one screw. Take that out and put the new truck on. Just take the screw in the washer. Like that. Simple as that. Now, just looking at this pad, and now you'll see it's sort of, I've already used this a bit before I've actually filmed this, so it's already got a couple of dirty sort of stripes on it, and I could replace this. I'm not sure whether I will, but here's a bit of replacement fabric. What you do is you just twist these up like that. You do the same on the other side. You can replace it, and then you push it back down to lock it in place. There you go. Presumably, once this runs out, you can buy some more. To be honest, I expect you can go to a fabric shop and get the right fabric. It's not just any old fabric. I think it's got a sort of corduroy effect where it's got threads that come up and loop round. In particular, it doesn't get caught on bits of track that are spiky and so on. So that's important. It's sort of quite velvety, perhaps. Anyway, you obviously want to have the right fabric. Now, the other thing is you need to have the right solvent. IPA is a bit of a standard go-to, and I've had reasonable luck with it. In order to fill it up, I need to take one of these lids off. Now, there's two thumb screws here. This one's for filling and for turning the drip on and off, and this one's for sort of regulating. So adjusting this controls a little drip valve at the bottom, and by turning this you can change the rate at which it drips. This one here, you can take this off for filling the thing up. There we go. So you put your solvent in here, but there's also a tiny little hole, and if you tighten this all the way down, it closes off that hole, and that prevents air getting in, which means the solvent won't drip out the bottom. So in order to start it dripping, you just open it up a little bit, not all the way, so if it falls over, you won't spill all your solvent, but just enough to let a little bit of air in, and that starts the dripping going. So to fill it up, it comes with a syringe, so I will use this to draw some IPA up. And then the end sticks in the hole. And I can use the syringe to put a little bit of solvent. Now it obviously has a maximum amount that it'll go in. I can't remember offhand what that is. And then we can put the lid back on. If I tighten this all the way up, it will not drip, in theory. But I can open this up, we'll drip solvent through this little valve onto the pad. And then as the pad gets drawn along the track, it will clean the railheads. Now the instructions do tell you all how to do this. It says here, adjust the drip rate to about 10 to 15 drops per minute or less. So maybe one every 4 or 5 seconds. And if you look carefully, you can see the drip rate. You can see the drops coming through. And as you adjust this valve, you can change that rate. So I think we're ready now to put it on the track and see if we can get it to clean the track. So here I've got the clean machine on the track, and I have my class 50 that I'll try and pull it with. So let's just see if we can hook it up. Nice. So there we go. So it's coupled up, no problems. And I did see they're just pushing. Oh dear. So it pushed it a little bit and then it sort of didn't go anywhere. Let's just try and pull it. There we go. So it can sort of pull it, but not quite. So and this is going to be the problem, I think, with this machine, is that you need a lot of traction to make it work. So it's clear that we need a bit more traction. So I went on eBay and I bought this. So this is a class 47. It's not really in keeping with my layout at all. Everything else that I've got has got the letters LMS written on it. But this is for cleaning the track. And I bought this because it was cheap. Very cheap. I got a really good deal on this, and I've just put in a hardwired decoder, just a simple decoder, no sound obviously, and in fact I think I did a live stream on doing that conversion. I fitted a digi hat on it and all that stuff, so I'll provide a link for that. Anyway, here we've got a bit more traction, a class 47. I think it's all set up, so let's just see if I can make it work. And it runs, so that's nice. So I'll send it backwards and we'll see if we can couple it up. There we go, that coupling's not quite worked. It's not coupled so well on the curve. There we go. So if we have both of them pushing, that works a bit better. Now let's see if we can pull it. So them both going forwards, set them running. And that works a bit nicer. Now, I don't quite know if I've got the speeds right and all the rest of it. There is a better way of running two locos together, and that's to put them together in what's called a consist. So let me see if I can work that out. Okay, so I use a Digitrax controller, and I've got it set up here. I've got the two locos that I'm using either side. And if I press the MU button, the multiple unit button, it says consist. Do I want to add or remove? And I think what it's saying is, do I want to add the one that's flashing to the one that's not? So if I press plus for add, then it says consist, and I think now, I think it's the, there we go, it's the one on this side, and they both respond to the controls on that side. Let me bring it back the other way. There we go. So that's a better way of controlling both of them at the same time. So I've now got two locos that I can use to pull my clean machine around the track. So now the big test is to see if it can go up the slope. Well, it's gone round that corner, which is also up an incline. That's probably one of the trickiest bits on my layout. So I think with two locos pulling, it's able, or it will be able to get up this slope. Sorry about the lighting, it's backlit by the window, that's not very good. So I should be able to use this in order to run all the way around my track and clean everything. But of course it's not going to clean anything yet because I haven't opened the valve for it to drip the solvent. So let me do that now. Okay, so we've done a full circuit, that's good. Now there is a problem, or a way in which this can all be improved. At the moment we're pulling the clean machine around the track. If the track's really dirty, then the two locos might struggle to actually drive across the dirty track. And in fact this was the case when I first started trying to do this. So obviously it'd make more sense if we pushed the clean machine around rather than pulled it. and that way the clean machine would cover the dirty track and hopefully clean it a bit before the locomotives got to it. Now I wouldn't expect the track to be sort of cleaned perfectly on the first pass, but it does mean that I can sort of clean a little bit, go backwards, go forwards again a little bit further, backwards, forwards a little bit further, and that might be a way of cleaning track that I can't reach to do by hand. So in order to push it, you need to get on the other side. So let's just uncouple and drive ourselves around. There we go. That's nicely coupled up. So let's see what happens if we push. You can sort of hear it struggling a little bit, but it has made it round the corner and up the hill. Let's see if we can keep going uphill. Okay, we're back on the workbench now. So the next bit of this was I discovered as I was trying to clean my track. Some of the areas of the track were so dirty that I couldn't really get the locomotives to drive across it, and I wasn't making much progress with my cleaning wagon. I tried to clean it a bit by hand. That helped, but I knew that I wouldn't always be able to do that. Now, part of the reason it was so dirty is because I hadn't used the layout for about a year. I moved house, and it's a whole other story. But I've moved house and spent time decorating the room to put it in. So I got a bit behind and hadn't really used the layout. So I was trying to get some life back into it. So in order to be able to drive across the dirty track, I thought perhaps what I should do is fit a keepalive. So let me show you what I've done. I know on this locomotive, obviously, as I say, I did a conversion and fitted a digi-hat and fitted a decoder. So let me show you. So here we've got the decoder, bundled of wires, move around. But just there and there is where the left rail and right rail get picked up. Here is where is the motor. So I've had to isolate this brush from the chassis using a digi-hat, which is just in there, and then obviously that's wired in, and the same on the top. But just here I've attached this little plug. Now I think this is a JST. Anyway, I bought a few of these on eBay, and actually I only need 2 connectors. This plug's got 4, and in fact this plug is still just a tiny bit too big. When I put the lid back on, it doesn't quite settle properly. Now that's partly because there's this little bit here where there's that indentation. So maybe I could try and grind that out, but better to get a different plug, I think. If you know a even smaller than this sort of connector, two-way connector that I can use, I'd be interested to know. It's also an issue with connecting locomotives to their tenders when you do conversions. So that I'd love to find a better way of doing this. But this is the smallest sort of connector I've found so far. Anyway, so here we've got a couple of wires coming out the decoder. Can't quite remember which wires they are. I think there's a common, is it a common positive? Or perhaps it's a common negative and one other wire. But anyway, the instructions will tell you what to do. But the point is, when you add a keepalive to a decoder, often you can put a sort of a little keepalive on, but if what I wanted to do is put a massive keepalive on. And the reason I put a plug rather than just wiring in a capacitor is that I want one that's, that won't fit under here. So when I need it, I can plug it in, and when I don't, I can put the lid back on. Anyway, here we go. This is what attaches to it. Now the point is, if you want a large capacitor or a large bank of capacitors, you need some sort of controlling circuit. And the reason is, if these capacitors are all drained and you plug it in without any sort of controlling circuit, then this will suck up a lot of juice, and you sort of overload things. So you need a circuit just to control the amount of current being drawn by the capacitors when you first charge them up. And this is one that I got from, I think it's Youchoos. I think this is Youchoos keepalive controller circuit. You can make your own. It's quite simple. I think you need a resistor, a capacitor, and an inductor. I think that's basically all you need. But this is quite a neat little solution, and it's not expensive. And they'll also sell you sort of 6 little capacitors, which are sort of correctly rated and a good size for N gauge. You see that sort of fits within the width. So here I've just wired them all together, soldered them all together. The capacitors connect to the controlling circuit and then a couple of bits of wire. I think actually these bits of wire could be more flexible, and we'll come on to why that's good in a moment. But it means what I can do is just plug it in whenever I want to. Let me have a look which way around to go. It goes that way around. Yeah, like I say, I could do with a better plug than this. But that'll do for now. And the problem is this is now waving around, so obviously I'll just get myself a 3-plank and under here a little bit of black tack. I don't know if you can see that. Here you go, just a little bit of black tack just to hold it together. So when I'm track cleaning, I can set this up, and it doesn't need to cause a problem. That can hook up, but actually the wire will drag it. So that's why I need a slightly more flexible wire, so I can couple this up and sort of have a better solution. But this is where I've got to so far. So I could use this and another locomotive, and if they both go over a dry spot, then this will just keep this one going enough just to nudge it all on. And get over the bits of dirty track. And using this, I've managed to drive my clean machine over dirty bits of track, and just keep going round and around until the track's clean. So this has worked out really well. So let's give it a go. Okay, so here we've got it back on the track, and it seems to work. So that's a good start. Let's just couple it up with the other loco. There we go. And now I'll just add it to the consist. There we go, so they're now together on a consist. So if I run it, so we've got the track cleaning wagon, a loco, and another loco towing its own little keepalive. So that's good. So in order to measure the force needed to move this thing, I've come up with this. I went and bought this thing. So this is a scale balance. Normally you'd hold it upright like this. You'd hang something from it, and the heavier it is, the more it pulls down, and then you can take a reading. And it measures in grams, but it also measures in newtons, because what it's actually measuring is force on the spring, not the weight of the object. So we can use this to try and pull the wagon. So I've attached a piece of cotton here to the coupling, and hopefully I can hook this with the spring balance. There we go. But what I can then do is pull, and we can see at what point it actually moves. So there we go, 0.05 newtons. It's quite hard to see, but that is just starting to pull at that point. So what's that? 0.06. Really what we need is a more sensitive spring balance. So this one measures up to 100 grams or 1 newton. But I did manage to find myself at a lot of extra expense, in fact, this one. Now I bought this off a website that specialises in equipment for weighing things like moths. It's a website to do with ecology and surveying insects and things like that. Anyway, but this measures up to 20 grams, and in fact it's got grams on the other side as well. There we go, 20 grams. It does have this little hook, this little clip, so that maybe makes things a little bit easier. So now, let's see if we can get a good measurement. So we were expecting it to be about, what did we say, 0.6 newtons? 0.06 newtons. Anyway, let's see what it comes out as measuring on grams. It doesn't really matter what the scale is, this, as long as we use the same when we make comparisons. So there we go, 4 grams, 8 grams, there we go. About 8 grams. Okay. So we're now going to do what is basically the same test, but going up the slope. I'd expect this to be a bit more. So we were saying it was about 8 grams when we were doing it on the flat. Let me see what happens in this case. So 7 grams, 8 grams, 9, 10, 11, 12, 13. And then once it gets going, there we go, it's pulling at about 10 grams. So it does need a bit more to go up the slope. Well, that's all very interesting. But I think what we really want to know is how much these locomotives can pull. So here I'm set up again, but I've hooked up the locomotive rather than the wagon. And if I just hold this tight,
There's a little bit of a problem here because we've got a metal clip, which will probably short out the rails if I'm not careful. There we go. So it's creating shorts, which is no good. So we try and hold it up. But if I just let the locomotive draw away, and we'll see how far it can pull the scale. So 4, 6, 8, 10, just over 10. Now you may remember they go about 11. Now you may remember that when just the one locomotive was trying to pull the wagon, it sort of maybe got it going, maybe didn't quite. And that's because it's only just about put enough force just to get it going. With two locomotives, it's no trouble. And in fact, I discovered while I could get it going on the flat, I certainly couldn't get it going up the hill. There we go, that's 11 grams again. And that's quite a consistent measurement. So this is good. This means I can run this test on all my locomotives and compare them. So here I've got the Class 47, and let's just run the same test on this one. Four, 5, 6, 7, 8, 9, 10, 11, around about 11 grams again, 11 and a half. So what this means is I can run this test on all my locomotives, and I can get an idea of how much each one can pull. And then I can also run the same test on rakes of coaches, rakes and wagons, and see how many coaches I can expect a particular locomotive to be able to pull. So finally, here we are ready to do the same test on my Stania 8F. Let's just hook it up. There we go. Hopefully we can see that. Let's give it a go. Now you can see rather pathetically it's pulling 3 grams. Let me try that again, put it back to 0 and try again. 1, 2. Two and a half. 3. So at the end of the day, I managed to get this little clean machine driving around my layout and cleaning all my railheads. It took a little while just to get all the tracks clean, but once I got it going, it was no trouble. And I've now got it, and I can use it to clean up the track whenever I need to. I also learned a few things about how many locos it needs. If you get one of these, you're basically going to need at least 2 big chunky diesels. And I shouldn't worry about trying to draw it around with a steam engine. They're clearly not very effective. If an 8F can only pull 3 grams compared to one of these diesels pulling 11, then clearly you need the diesel just for doing this. Even if you've got a steam-based layout, I got this very cheaply. Anyway, thanks for joining me for that. Hopefully I'll see you on the next video.